All right, we've got a little topic today, mostly in Fusion, but also in Prusa Slicer, things like that. Mainly working with STL files directly. So there was a question I got. I don't remember if it was email or Discord. I think it might have been in Discord about how you can edit STL files. So it's been a while, but earlier, let's see, earlier at some point we did talk about Mesh Mixer. I'm seeing if I can find where we might have done that. Maybe I didn't. Oh, there it is. So it's been a while. Class 8 looks like when we talked about Mesh Mixer. That's the tool I normally use if I'm just trying to like combine meshes together. Like I've got going to Thingiverse and I've gotten several different things and I'm trying to combine them together into one type of mesh that I can print all at one time. I usually go to Mesh Mixer for that. It's an older piece of software that isn't really even maintained anymore. Autodesk owns it, and they've been incorporating a lot of its features just directly into Fusion. So a lot of those older pieces of software, it can crash on you sometimes, and it doesn't do all the things you might want it to do, but it does do some things better than most other software that I know of, at least at that free level. So, because Mesh Mixer is free, so you can get in there without any cost at all. And so that's what I normally do. But if you want to do something more precise, so you've only got the STL file, you don't have the actual CAD model files to work with, but you need to change a hole diameter, or you need to, add some feature that's not really just slapping on another STL file and merging them together, but you need to add something more precise, then Mesh Mixer could do that, but it's going to be a little more difficult. And in that case, I probably would at least try to work in Fusion. You can do some of these same things in SolidWorks, but I haven't spent as much time using SolidWorks as, that's a weird, SolidWorks mesh tools. They do have mesh tools, I just haven't used them very much. So I normally go to Fusion if I'm trying to do something precise. So that's what we're going to look at today. And I've got a little bit of not mesh mixing, but something like that you can just do directly in the slicer. So we'll use Prusa Slicer for that. So before we get to that though, we did print our little nozzle holder. So this is TPU, so it's a rubbery material. I might need to move the camera back somewhere over here. So here's it. Remember, we made a lid for it and a little base. It has several strings. They actually show up worse on camera than they do in person. But well, I don't know if that's better or not. Well, we'll leave it like that. These strings are easy to get rid of. Either you can just pull them off, or you can hit them with a heat gun, something like that. A little bit of heat, and they'll usually almost dissolve. In this case, they're not very heavily stringed. But TPU, remember, this is TPU, so this is a rubbery material, and it is going to be more stringy. Just for one, it's rubbery, but also it's hard to use retraction on this material, or it's not impossible, it's just harder to use retraction. Now we printed this on the little V0 here, so we've got a direct drive setup here. So there's, well, still not on the screen, there's a stepper motor. Actually, you can very faintly see the top of it here, that is directly feeding the filament into the hot end. So those direct drive printers are better at dealing with these flexible materials. This particular one was TPU from, what was a weird name, Giant Arm, I think that's the name of it, Giant Arm. I don't know that I've ever printed any of their material, but it printed fine. It came out well. I did have one failure here. Let's see if I can get it to where you can even see the failure. Yeah, you can see it there. So, and it wasn't because of the TPU. It was because of the printer. And it wasn't even because of the printer exactly. It was really the slicer. So let's see what the failure is and then explain all of that. So it was printing fine. But you can see, like, oh, there's a good example. Where's that one? Right there. See that circle? It's supposed to be over here. this is one of the circles that the little nozzles are going to fit down into, but it's over here, not in the same spot. So that's called a layer shift. And I happened to, actually I heard it in this case because of the way the printer's set up, but I saw it after I heard it and just stopped the print. It would have continued printing, but everything would have been shifted over by quite a bit. So, here's where it was printing after the layer shift. Here's where it was printing before the layer shift. So it wasn't even close. It wasn't like I could just let it print and then, well, it'll be off a little bit. No, it was going to be not even close to lined up. So what causes layer shifts in this printer? So remember, we're on the Voron in this case, so it's a Core XY printer. And one of the things with Core XY printers that you're trying to do usually is print pretty fast. And one of the things that can speed up your print is your acceleration. So being able to move the print head, accelerate it, not the velocity, but accelerate it from one position to another, one direction to another direction or whatever, is to get that acceleration very fast. And it was set to like 20,000 millimeters per second squared, which some printers can do. This Voron, it's a, I haven't really tuned anything on it. It's using the kind of standard size stepper motors, so they can be low on torque. And when it went to do a travel acceleration move, so it's not even printing, it's basically I had this guy and the lid next to each other, and it was over here, and it needed, I don't know where it was going, but it needed to go from here to maybe over there to start the next layer. And that movement, the travel velocity wasn't necessarily that bad. It was a little high, but the acceleration was so high that you actually could hear the stepper motors not be able to make that. They made a grinding sound, and it just couldn't do it. They didn't have enough torque to move the print head with that amount of acceleration. So instead, they did the best they could, and they got close enough, but well, not close enough. They got close, but they were off by some amount because the steppers were asked to do some movement that they just could not do with their current and torque capacity and all of that. They just couldn't do it. So layer shifts don't always happen in that sense, where there's a travel, but a lot of times a layer shift is associated with too high of acceleration. It could be like on a bed slinger printer, like the Ender 3s and those kind of printers. It could be same thing. You could be asking for too much acceleration, or you could have a belt that's just a little bit too loose, and it might skip a tooth. When it's asked to move really fast, it might skip over one of the teeth or something like that. The stepper motor could still skip a step because it's asked to do more than it can do in the time frame. So if you see something like that where it was printing fine, but then something caused it to print in a new location, things aren't lined up, that's called layer shift, and it's usually related to an acceleration being too high or a loose belt, or both. So what I had to do was we were using Orca Slicer, and I had to go into our, not our material, our printer. Where's the printer? Here it is. And I had to edit the motion ability. So different printers use different words for all this stuff, and I basically halved the acceleration. Now, the maximum acceleration for travel is actually for a clipper printer. It's actually in the printer config file, so I went in the config file and changed it there. I also changed, in the speed settings over here, I also told it, lower acceleration limits on the normal printing. So I've divided them by 10 in that case. So that's the travel speed, still kind of high. It should be okay for a Voron style Core XY printer, but it was fine when it printed again. But some of these travel speeds are usually where the layer shifts happen. It's not necessarily on the print itself. It's usually when the print head needs to travel from one part to another section of your print without actually trying to extrude anything. So if you get layer shifts, first of all, check to make sure your belts are tight. because it's possible that a belt just was loosened somehow. I did check that first on this printer. That's a little bit different on the Core XY printers. They do have belts, but they can be, since they work together, there's two belts working together to move the print head. You can have one that's tight and one that's loose, and that inequality between them can mess up all your prints. But usually on a bed slinger type of printer, you just have one belt per axis, and it could just have gotten loose somehow. So check that first. If it seems fine, then go into your accelerations in your slicer and see what they're set to. If they're very high numbers, now for a bed slinger, 2,000 millimeters per second squared is a pretty high number for acceleration. For a Core XY, that's actually kind of low. So you do have to have an idea of, what's a decent number for your printer. So you might have to Google, your printer and kind of a conservative acceleration number. So that's layer shift and how you can diagnose it and deal with it. So we did get our stuff printed, got our little box printed, and it's got a little lid, and it works pretty well. So we did get that to work. We designed this in Fusion. It's been recent, maybe on Monday. Might have been Monday that we did that. So what we're going to do today is, what if I posted this on Thingiverse or wherever, but only the STL file, and you go download it, but you want, I don't know, you want a different size hole in here, you want more hole, you want to put some nozzles in between there or whatever, you want to change it somehow, but you don't have the CAD model to go and edit the history. So all you've got is the STL file. So that's what we're going to do today. So let's, we don't need Orca Slicer. Nope, we don't need to save that. Oh, actually, so see, there's where I reduced some of the accelerations. We will save those, actually. All right, so Fusion, here we are. All right, so I've already downloaded the STL file because I made the STL file, so it's already on my computer. We've already sliced it and printed it. So in my case, this would not be the best way to do this because I actually have the CAD file, the actual Fusion file. But assuming you don't have the Fusion file, all you have is a STL or something like a STL, so a OBJ or a step file, one of the generic files where it's no longer a solid body. It is a collection of triangles. So the STL files, they're not solid. They are just like a skin made in a bunch of triangles. So the more triangles you have, the better it maps to whatever surface you're trying to create. But they're still just triangles. They're infinitely thin, and there's no actual geometry volume in there. I guess there's geometry, but no volume. So you're in Fusion. Let me make sure we can see all of our buttons. There we go. Okay, we're in Fusion. We've downloaded our STL file. So one of the first things you probably want to do is insert the mesh. So all of the STL files, OBJ, all of those are mesh files, meaning that they're just a mesh of triangles, and they're not any thickness to them. So we're going to insert mesh, and you have other things you can insert here, but insert mesh. I'm going to find wherever there's a spoon. That's not it. I think it's on the desktop. There it is. That's so this is actually a 3MF file. So when I exported it out of Fusion, I used a 3MF file. That's a more recent development in the mesh world. It contains some other factors, print settings, things like that. Now this one did not because it came straight from Fusion, but it can have other information. But it's still, at its core, just a collection of triangles. Actually, just a collection of like vertices of where triangles go. So there it is. That is the one we want. Actually, that's both of them. So here it's bringing it in. I'm going to go over to this little insert mesh dialog box that popped up. I'm going to center it. This one is centered. Now this one, we created in this software, so it's going to already be scaled and everything correctly. But it could be that whoever made your model that you're working on, they made its origin somewhere totally different. So it's usually best to center and then move to ground so that your workspace is centered with your origin. And then I'm going to flip it around because looking at, oh, you can't see that. Looking at our little gizmo here that tells us the orientation, I'm just trying to make it look like, well, yeah, that looks like the top, and they've got the top there. Front, I could be convinced any one of these sides is the front, so that's good enough. But I want it to line up with that, just to make things simpler later on. So I've done that. So okay, so now I've got a thing that looks like kind of what I normally see in Fusion, except there's a whole bunch of lines in there, right? Those lines are the triangles. So you can actually see them on this curve here. There's all the little triangles. So I can select it as a not a body. Actually, it did come in as a body over here in the body category, but it's called a mesh body. So it's just a mesh. If I go into inspect it, actually I don't even know if I can do this. Fusion. So your experience will probably be a little better than what I've got going because I'm streaming and all this. So Fusion's going to be a little slow. One of the things that could happen, this is a relatively simple piece of geometry because it's just kind of cylinders and sidewalls and things like that. So it's not very organic at all. But some models will have millions of triangles. This one does not have that many. I don't know if it'll tell me. Let's see. Properties. I don't know if it tells me. Mesh. Again, it's being slow. So I've got 4,000, a little over 4,000 facets, which are the triangles. So that's a relatively small number of triangles for this kind of thing. But you might grab something that's a very organic, like a figurine or something like that, and it's got millions of triangles. So it could be that some of these processes are not going to work, or they're going to be extremely slow on models like that. After we're done with this one, I'll try downloading something that's more like that and see if Fusion can even deal with it. It probably can't. And then in that case, I'll probably just, well, probably if I am trying to do something with an organic model, I don't really need what Fusion's going to give me as far as the precise hole cutting and all that kind of stuff. And I would just take it to Mesh Mixer. Mesh Mixer, it's still going to have issues if the model is millions of triangles, but it can still do it. It's just going to be a little more suited to that kind of thing. Okay, so we can close this. What do I want to do now? Oh, let's inspect it. Let's see if I can do a section analysis. I don't even know if I can. Oh yeah, so there we can. But see, look inside. There's nothing solid in there. You can actually see it does, you know, render a wall, but it's infinitely thin walls. So there's no solidness to this mesh, and that's a problem when it comes to doing all of my tools I would normally do on here, because it's not a solid mesh. So the first thing I need to do, assuming that I want to, maybe I want to change the diameter of these holes. They were too big and I need them smaller, or vice versa, or whatever. I want to add a hole. Any of those things I can't really do to the mesh. I do have mesh tools over here where I can directly edit the mesh, but it's going to be way more complicated. We did a similar thing. It's been a while, but we did a similar thing where we scanned in. Actually, I think we did photogrammetry. I don't remember which process we used, but we took in a model of a Camry, the rear part of a Camry, the trunk lid, and modeled a wing on top of that. And we did most of that just in the mesh type tools, in the surface type tools. Well, not surface, it was more in the mesh tools. And so we directly edited there. So you can do that. But if I wanted to do something that was more like CAD modeling to this file, like changing the size of these holes, I need to have this a solid piece of geometry. So one thing you'll see if you watch a lot of these videos is the first thing they do is they go over here and they turn off capturing design history. Do not capture design history, which is valid, particularly if your model is that's not what you want to do. You're not trying to create a engineering type model. You're just trying to modify it in some way. It will make some of the mesh editing easier, and it'll even give you options you didn't have before on mesh editing, like we did with the wing model. But if you don't have to do that, if you can actually keep your design history is basically on here, let's down here at the bottom, and SolidWorks kind of keeps track of it along the side here, but Fusion keeps track of it at the bottom. It's all the little steps that you've made to create the geometry. So right now I've got one step, import a mesh. That's basically what I did. But if I had created this geometry before, you know, it'd be draw a sketch, extrude the sketch, cut some holes, do a fillet, you know, whatever all the little processes were. That's the design history. So if you can keep that, then you can go back and edit all of that stuff later on. So, but if you turn off, you know, right click, do not capture design history, then you can't go back and edit. You can't just slide this little slider around to some previous step and edit it and then have it affect all of your other steps. So it's better, if you don't have to not do that. Don't turn off the design history unless you have to, or you know that you're not really trying to create that kind of model. You're just trying to edit the mesh in some other type of way. So I'm going to try to not turn off the design history, keep that on, because of what I want to do with this model. All right, so plus Fusion is constantly developing tools here, and some of those videos are older, and it might not have even been possible for it to do some of the things that we're going to do today. So this is the updated, you know, as of 2024 version of Fusion. So if you watch this a long time in the future, it's probably an even simpler process. Or if you have actually Fusion doesn't let you run old versions because it's kind of sort of connected to the cloud, and so it'll keep updating kind of over here. Actually, I don't remember which one of these buttons. One of these kind of keeps you updated. So first, let's let the mesh tool. So I'm in the mesh tab across the top here. Normally you're in solid, I'm in mesh, and I want to prepare this model for the next steps. So it gives me prepare, and it says generate face groups. So what it's doing here, and it kind of gives you a little picture with these pastel colors, it's trying to go in and it's trying to identify what groups make sense as a surface. So obviously, like the flat areas, they look like a surface. The flat top here looks like a surface. These rounded corners, that looks like a surface. But what they are right now is all these collections of triangles. So I'm going to prepare, and I'm going to generate face groups. I'm going to do this part. I'm going to leave the lid alone, kind of as a side-by-side comparison to see the differences in what's happening. And so I get this pop-up, and the first thing I select is what do you want to generate face groups for. Since I have two different meshes here, I've got to pick one of them, or both of them. You have two options, fast and accurate. I think in this case I want to do accurate because our mesh wasn't that big, 4,000, 5,000-ish. I think it was just over 4,000 triangles, so it's not huge. In fact, if it is a large mesh, it'll give you a warning that, hey, this might take a while, so if I can do it at all, you might be sitting here for a while. This one, since it's under 10,000 triangles, it will not warn me about that. So I'm going to do accurate. I do get a level of how accurate do you want to be here, and I'm just going to click OK. Actually, preview. And then it says, oh, I'm going to generate 53 different face groups. I'm like, okay, that sounds good. And I could change the tolerance and get more or less face groups if I wanted to. So it takes a little bit of time, and I don't know. So actually, that wasn't that long. That was pretty fast. Because this model is already a CAD type model, it's not an organic figurine or something like that. It's just kind of surfaces, cylinders, flat planes, that kind of stuff. So it doesn't look any different. So let's go into inspect and look at display mesh face groups to see what it did. So on the left, we didn't, on the lid, the part on the left here, we didn't actually do any face groups, and so it's just all one group. But here on the one that we generated the face groups, you can kind of see this color-coded set of patterns of what it's deemed as a group of faces. And so it has already gone through and tried to identify, hey, all of these in here look like a hole. all of these look like a flat plane. All of these look like a curved surface. And so it's tried to group them together. And apparently there's 53 of these groups in our model. Okay, I probably don't want to look at that all the time. Shift F will turn that off. Shift F will turn it back on. Or you can go into your inspect option here. All right, so we did that. That just kind of pre-set up the model. If you did run into trouble with, hey, there's too many faces, there is a modify option here in reduce. And you can even see the picture here where it's got this nice smooth looking curve, but then once I reduce it, it's very faceted. You can reduce at some percentage. If you have 20,000 triangles and you're trying to get it down to 10,000, then you can go for a 50% reduction. You can choose uniform or adaptive meshes. Uniform for this model would probably be better. Adaptive for something with lots of curves would be better. And then we could preview. I don't need to reduce this one, but if you needed to, then that would be the way to do it. All right, so we've kind of prepared our mesh in the sense that it has gone in and identified face groups. Okay, so now we can modify, we can convert this mesh because we want a solid body. We want something that we can actually extrude and cut into and all that. So I'm going to convert mesh, and we'll select the one. We're going to leave the lid alone and just keep it as a mesh so that we can kind of compare side by side. I've got all these options here. So I've selected the body. It's already the blue piece. Do I want it to be parametric or a base feature? So my goal is to convert this thing back into a solid body that I can go and do CAD operations on. Extrude, cut, all that kind of stuff. So I want a parametric one. I want to keep that design. I want to create a new design history for this thing. It'll start with this. It's not going to go back and create a retroactive design history of me creating the holes and the lip and all that kind of stuff. But from this point on, I would like that. So I'm going to go for parametric. If I don't need any of that design, I don't intend to keep design history, then base feature is going to be fine. But I want to try parametric. Then you've got 3 options here on the method. Depending on the version of Fusion that you're using, you may only have this first one called faceted. So, and that'll work. It is not the best one, but at least it'll convert it over. It won't look any much different than what it looks now, but it'll be solid. So if that's all you have, then that's what you use. I am going to use Prismatic because I've got the education license here, which if you have a .edu email, you should be able to get that. And what that will do is it will turn these into those face groups. It'll kind of merge all the face groups into surfaces, and it'll be solid. If I had a very organic model, when I say organic, I mean something that's, it's lumpy and it's like a figurine where it's not just flat planes everywhere and cylinders, then I would use the organic, and I'd go through these options of, well, how precise do I need to match this to the original geometry? I'm going to do prismatic because I think this looks pretty prismatic, and I have the option to. So click OK. Now I've got something that looks a whole lot more like what I expect something CAD modeled in Fusion to look like. Let me go undo, and let's say that you don't have the parametric option. So modify, convert mesh. We'll keep parametric, but we only have the option for faceted. Okay. So doesn't look much different. Actually, the lines look darker now because I've got both of these showing. Oh no, that's the other one. It's now a solid. Let's do inspect section analysis. I can actually click that plane now and notice the difference. I've got solid cross section here. I've still got the hollow nothing on the lid over here because I didn't do anything to the lid. Okay. You can still work with this to make it more like what we had before. So let me show you some of the reasons you might want to do that. So let's go to the render option over here. So I just changed the tool from design to render. The workspace is what they call it. It's thinking. This would probably switch faster if you're on your own PC and not trying to stream at the same time. So it's taken a while. What I want to show, and this might take a really long time, so we may not can do it. What I want to show is why you might not want to do this process if you don't have to, if your goal is to render anything. So let's go to our Appearance tab. It pops up over here. Mine was actually minimized. So let's pick something. Let's do this metal flake. So we'll do some blue metal flake, and I'm just going to color this guy with blue metal flake. So notice how when I start the render, and again, I don't know how long it's going to take, I get some weird effects based on the fact that actually, you know what, a wood grain might show this better, and it might be faster. Let's do that. Let's see, let's find a wood. Powder coat, no. Wood. Mahogany, that looks like it would probably show up these issues. Yeah, that'll show up easier than the metal flake. I thought the metal flake would show up, but it's a little too random. But see how you can see the effect of, like on these front two planes right here, you can kind of see how it looks like, it looks kind of wood-like. Now, if I'll have to let this run for quite a while for it to look more like a real render, but you can see the effect of having these two different triangles here on what it does to the texture that I want to apply to it. So if my goal is to create something that looks like a render, then all these little individual triangles are kind of going to mess that up. Over here, you don't even get any real wood grain. It's wood colored, I guess, but the wood grain is so divided up into all the little triangles that you don't even pick up any of the wood grain. This one actually looks kind of interesting because it looks like it's a box that was made out of lots of little pieces of wood all glued together. But maybe that's not what I want. But I'm going to get that effect because of all the little triangles. So let's go back to our design space. Actually, now you kind of see it even on here. If I only have the option to do the faceted conversion, then I could just click on one of these faces and delete it. And most of the time, SolidWorks is pretty good at merging faces together when they're in the same plane. Actually, that one merged the whole thing. I deleted one face there and it merged the whole thing together. It's not so good on doing that with the corners here. For one thing, you got to select all these things, but if I delete that one, it doesn't really, it's trying to flatten it all out, so it doesn't work too well on curved surfaces, but you could at least get a little bit of your effect that you were going for by just going through and manually deleting faces to where you're combining things together. So that's one way you could do it. For these curved surfaces, what you would have to do if you wanted to get rid of all these little triangles but maintain the curve, you'd have to delete all of these things and then replace them, with your modeling tools, replace them with a curved surface. So that'd be a little bit of a pain to do. So, but now if I go to my render, now you can see at least I'm getting these flat surfaces are all considered all one surface, and my textures will show up more correctly. So that's nice compared to what I had before. All right, that's actually not what we're trying to do though. Though we might go back into the render depending on how much time we have. So what we were trying to do is we wanted to change these holes. So let's actually undo a bunch. Oh, also notice I've built up a lot of design history back here that I can undo. Actually, I want to get rid of all of this stuff. I don't want the render. Let's see. I think this is the stage. Oh, that's the convert. Let's edit our conversion here. And let's say that we do want the prismatic version. All right, so now we've got more like what we expect to have. And this surface is all one surface. It's not a bunch of little triangles anymore. And so it's more like what we wanted. Okay, and if we inspect it, you know, it's a solid body. Okay, so now what I can do is I can go in and I can do all my normal operations. So if I want to create, I'm back in the solid tab now. I want to create a sketch on this surface. These holes were too big, so it even picks up, you know, I can snap to the center of that hole. It's being slow. So there we go. We can dimension things. I can dimension from there to there. Let's say that it was I needed an extra wall. My walls were 0.4 millimeters. So let's make that 0.4 millimeters. Finish the sketch, and then I can go in here, take that surface. I can extrude it like I normally would. I can extrude it down to let's see, down to distance to object there. And that hole is now smaller than the others. You know, I can edit it. Maybe, you know, maybe I wanted this face over here. I want to create some text on there. So, let's see. I think I need to draw a sketch on there first. Create text. We'll put it on that surface, kind of like that. This will be nozzles, and that looks fine. So we can finish that sketch. Now I can take those, extrude them. My wall thickness is 0.4, so minus 0.4. We'll extrude it into the thing and cut away one layer, and now I've got an embossed nozzle word on there, so I can edit it like I can before. And down at the bottom down here, I'm building out my design tree, so I can go back, or design history in this case. I can go back and edit any of these things. Maybe that hole diameter was not what I wanted. I could go back and edit it. If I turn off the design history to do all this stuff, then I have to kind of just start over when my editing, if I need to change something. I can't just easily go and just edit the feature. Here I could go back, edit that sketch, and say, oh, you know what, that was too much. I only needed 0.3 here, or negative 0. No, that was a distance. And it changes the hole based on that. So versus having to recut the hole. So that is the best way, assuming you can, the best way to deal with STL files in Fusion. First, you import, so insert mesh. So you downloaded the mesh, your STL file, insert the mesh. Then you go to your mesh tools, you prepare, so you have to decide. So it might tell you that you can't generate the face groups, or it's going to be a really lengthy process because of the number of triangles. In that case, you go to reduce the mesh to try and get some of the unnecessary triangles out. You'll lose some detail if you have, if there was a reason why you had all those triangles, you'll lose some of the detail. But in order to operate on it, you might have to do that. Then you generate your face groups, and then you convert your mesh, do the parametric and the prismatic if you can. If you don't have those options, you should have the parametric option. And if you can, if it will let it work, then I would use parametric. But if it won't, then you can use the base feature and just edit the mesh directly, like moving points around, similar to what we did with the wing design for the Camry. So that's the general process. Let's see, I haven't tried this part. Let's go and see if we can find something that's more organic looking. Oh, here's a bunch of Pokemon. So they're organic looking. Let's see what happens if we try to get one of these guys. Where are the files at? Oh, this is one of those where Oh no, there they are. Let's find one that even looks printable. This guy, he looks printable, but he's more interesting. I'm just scrolling to see if there's any that look better than others and still printable without a whole bunch of support material. Let's go with this one. So mine says open in Cura. You can connect Cura directly to here. I'm just going to download it though. All right. Let's see what happens if we try to do this. So let's get a new file. Actually, I don't need to save this one. We can just close it. Don't save. And let's insert mesh from my computer. That should be in downloads. There it is. All right. We have a huge number of triangles. You can already see. Look how tiny they are. You can, oh, look, you can also pop inside it and you can see that it's completely hollow, like all meshes are. So I'm going to center it, move to ground. This is one. All right, so let's rotate it to where top is on the top. There we go. That looks okay. So let's just see how many. Right click, properties. It might take a while, I don't know. Oh, my properties tab was closed. Let's see. Where are the mesh numbers? 370,000. So a lot of triangles in here, but it's very organic, curvy, lots of geometry there. So it is going to take a lot of triangles to represent that. It's probably not going to work very well to use this directly, just because the processes that Fusion's going to try to do are going to be too slow, if it can do them at all. One face group, because we haven't divided it. Let's see, let's go to our mesh tools and let's see if we can do any kind of reduction here and still get our you know, mainly our model to still look decent. This one's going to work better with adaptive versus uniform. Uniform probably wouldn't be much different at first because the triangles are so small already and they're roughly the same size, you know, but you can kind of see some are skewed, some are really long and stretchy. But let's try to do adaptive, and let's just try to half. So that'll still be, we were at what, 320? It'll still be 160,000, but let's see. It does give me a little progress bar down here that it's trying. I don't know if it crashed or it just went away. Oh no, it actually worked. All right, so you can already see that I'm losing some detail here. The triangles are getting much bigger. Let's see where we're at. You know, it should be half of what we were before. Actually, it's 185, so I don't think that was half of what we had. But it's still way too many for a lot of the things we want to do. So, and it doesn't look bad. Doesn't look too bad. Let's add a different material, though, so that we get a better idea of what's going on here. Let's go to our... I thought I could add them here. Doesn't want, oh, maybe if I am in the solid tab. Everything's kind of slow trying to go between different things. Maybe we'll just let it try to reduce again. Let's try another 50%. Not sure why it still looks reasonable. Doesn't look horrible. I mean, it's starting to get a lot washed out compared to what I had. You know, there's a lot less detail in here in the curves and everything, but it's still recognizable. Let's see where we're at on elements or triangles, facets. 92,000 is still a bunch. All right, so we could keep going with that. Or we could be more aggressive. You know, we could reduce, and instead of trying to do 50%, we could try to get down to, I think I can type in here, 20%. Okay, so it's getting more and more low polygon look to it. Let's see where we're at. 18,000. Maybe it can work with this. Let's see. Let's try to generate face groups on this guy. We're probably not going to be able to do accurate. Let's do fast. And let's just preview that. That didn't look horrible. It didn't look horrible. It's going to do 7 face groups. So let's see what they look like. Shift F. So basically the body, the arms, the face, the legs, and the 2 feet are separated now, which that's actually kind of nice. Obviously we've lost a lot of detail, but now let's try to convert this guy to a mesh. I don't need this one to be parametric. I'm probably not going to think of this as a CAD model. So this is probably a base feature. Although if it'll do parametric, then let's do that. Here, this option, you might have this symbol. Oh wait, it's off the screen. You might have this little symbol up here. This little plug-in symbol. What that means is that there's a plug-in. I think it's the design plug-in. And if you have the education license, I think you can rent out for free the different plugins for like 30 days, and then you can do it again. And so that one is organic. If you have the plugin symbol, then you have to go to your plugins extensions, is what they call them. And I think it's, yeah, mine is active on the design one. There's actually 3 of these. But you have to request that, and it's just click on it and start access, assuming you have an education account. So let's try the organic. Let's see, resolution is going to be by accuracy, or we could just say by how many faces you want to have. Let's go with high accuracy, and I'll uncheck pre-process holes because there are no holes in here anyway. And let's select the body. We have to do that. All right, so see down here, this mesh has more than 10,000 triangles. Calculation will take a considerable amount of time. It doesn't say it won't do it, or at least won't try to do it. It just says it might take a while. I wonder if I change this to base feature, if my warning's still there. Let's just see how long it's going to take. We might have to come back to this. I don't know. All right, I think it's operating. You kind of see the screen. It's refreshing and that. I think it's doing something, trying to do something. But remember, we started with 350,000 triangles. A really high detail model, and now we're down to 18,000, which it still is warning us that might be a problem. So it's doing its thing. We might have to go to one of our others and come back to this to see if it does anything, though. Also, some things in general while this is processing. Oh, I think it's finished. So, it did finish. If you are doing something like this, then a lot of you are on laptops. I'm on a desktop here, but a lot of you are on your laptop doing this kind of thing. Unless you have gone in and changed your power saving profiles on your laptop, then unless it's plugged in, if you're running on battery power, then the processor is probably automatically speed limited to 50%. So if you're doing any of these heavy duty operations and you're on a laptop and you're not plugged in, then you're probably running at half speed, and it's going to take even longer or forever. So if you're on a laptop, either plug in, that's the best option, and your power saving profile should not be active in that case. Or if that's not possible, then go into your power saving profile and tell it not to throttle your CPU while you're doing this kind of thing, so that you get your maximum processing. Now, it'll run your battery faster, but that will at least make these kind of processes a little shorter. Here you can kind of see all of what we've got. It's kind of hard to read with all the lines on there, so maybe let's go over to our render And let's give it a more flat material. Let's see, what do we have? That's not a wood. Oh, let's give it a stone material. That would be interesting. What do we have for stone? We have marble, white marble. That's kind of interesting. Oh, this little symbol here means I need to download it. So I'll just download it. And then I will drop it onto the whole thing. You can drop to faces and download or color different pieces individually. I don't know if it respects face groups though. Let's see. Oh, I can't copy the same one. Let's just do plastic. Oh no, the plastics take a long time to render, I think. Let's do this yellow thing just because. Oh, I got to download it too. So I'm on faces. Yeah, it doesn't seem to. It wants to do like. I don't know, it's kind of weird how it's acting there. I think maybe in my selection group, not in here but in the design, I might can select face groups and then I could apply materials to individual faces. Really all I wanted to do here though was to check out what kind of geometry do I have with less of that shiny material and more just a flat material. It actually looks pretty good. There's a high level of detail there. You know, it's not bad. Some parts that are going to be hard to print, you know, all under there is going to be hard to print without support material. But that looks kind of reasonable. Let's go back to our design. You can also turn off this wireframe. I think in our display settings, visual style, we can just do shaded. There we go. And it's picking up that material that we had before. And it'll give it a little bit easier chance of reading it. We can do our inspect and face groups. Oh, no, not face groups. Section analysis is what I want to do. And see, it's all solid. So we can do things that we could do to solids now. And, you know, if we need to edit it, we can edit it as if it's a solid. Like maybe we want to add a base to it so that we don't have to worry with all this stuff going on under here because we want to print it. So we could go in and we could do that. We could select the surface, pick something. Actually, we probably would be better off. Oh no, that's on the bottom right there. So we can collect that surface and create a circle, kind of pick the center, something like that. Finish. And now we can extrude that kind of up. But so see, it's cutting away over here in our operation. We could say, let's just make that a new body. And now we've got something that, okay, now maybe I can print this. There's still some gaps in there, but I could bring it up higher or whatever. You know, I could flare it out with the chamfer tool. Chamfer always confuses me, so I might have to figure out how to chamfer it the right way. Oh yeah, that's the other way. So not that one. That one. There, we can make it a little more interesting. You know, you can do a lot of different things to try and make it more printable. And I can edit it, and it's one model now. Actually, I made it two bodies because I added that other feature there, the base. You can still do your mesh tools where we can modify this arm position, I think. So modify, actually I may not can modify because it's not a mesh tool. So if I wanted to like deform it and all of that kind of thing, I think that would be the instance of do that while it's still a mesh, you know, reduce it down. But now I've got a body and it's a little bit harder to modify the body. You do have this form tool, but I don't know that that's going to work with modifying this. Sculpting in Fusion is not a thing that I've done a lot of to know how to move that around. Yeah, it doesn't really let me. Actually, it's locked up. So The body could not be repaired after. All right, so yeah, it doesn't like that. It did try to move that, but it's a little frozen. All right, so there it went back. Yeah, it doesn't. When it's a solid body, it doesn't respond too well to moving like this, like the mesh mixer tool does. I think I would need to either convert it again to a T-spline model, which I've got to let it, it's got to give me control back. It's stuck. This is one of the things that can happen that I've noticed with Fusion and trying to do some of the sculpting from a body, is that it doesn't like it. So, all right, it gave me control back. So I was going to say that we might can modify this. Well, no, not that one. This one. And I thought we could. It's not a mesh anymore. Yeah, I think it might be in the surface. Yeah, I can't modify it that way. Let's see. Maybe I'm kind of stuck with it this way. I could create a component, but I don't know if I could convert it. I need it to be like a T-spline or a form in order to go and reposition it at this stage. I kind of need, I wonder if I can, hold on. I wonder if I can go all the way back in my design history to when it was still a mesh. I wonder if I can edit it here. Let's see, I don't know. So I've got the move tool, and I can move faces. So let's just say we get, oh, it doesn't like, it wants to select everything. So it's, yeah, it's just selecting everything. I'd have to investigate how I can modify it as a mesh retroact, or like after I've already converted it to a model. I think there's a direct edit mode right here. So I'm going to see if it'll let me do that. This is similar to what we did. So our selection type is paint faces. So why don't we just try and, it's letting me do it. And it does go through the model. You can turn that off if you don't. So if you don't want it to, you only want the top, then you can turn it off to only select the front side. So we've selected those. And, oh wait. I wanted to edit them, but it's not really. That's all that doesn't actually do anything. It lets me select them. And then what I want to do is I want to move them . Oh, I have the option to select face groups, but oh, there I don't have any face groups at that point in my design history. So it's selecting everything at once. Huh. I'd have to figure out the right order of things to do that, because it's trying to select everything at once. Yeah. They're all connected together as far as what it's letting me do, even though I'm in faces. All right. Well, so it might be difficult to reposition things after you've already converted it over to a face group. Although I think there is a way to do this. I'm just having trouble figuring it out. All right. So let me quickly switch over to, well, the whole point was now I can, well, if I go back to the current time, cancel all of these things, then it is a solid model that I can do solid model things with. It has been reduced in the number of polygons it has, the number of triangles it has, but it didn't reduce it to the point that it's not usable. So is this the right, like I said, normally if I were working with a model like this, I'd probably go over to Mesh Mixer, just because it does let me like sculpt on it with sculpting tools and all that kind of stuff. It's pretty easy to reposition things, where Fusion is not as obvious on how to do some of that stuff. But if I were trying to work on something like our little nozzle case, the box, where I want to change hole sizes or add holes or text or anything like that, then Fusion is actually an easier process. All right. Oh, it's reconverting the mesh, and it's redoing all the stuff that I had rolled back in my timeline. Let me show you. We've got like 10 minutes. Let me show you over in Prusa some stuff you can do there. Now, this is not necessarily STL modeling, although I guess you are using the STL. Let's get the same one here. You can do a lot of those same things. You can add text. You can. It's a little bit harder to maybe change the size of these holes. But let me show you one thing you can do. And that is, maybe when you're printing this thing, you want the area around the holes to have more walls than everywhere else, because they're too weak, or maybe these aren't holes for nozzles, maybe these are holes for your heat set inserts or whatever, but you want more walls here, but you don't really want more walls everywhere else because it takes longer to print. You can right click on your part in Prusa, and you have this little tab here, add modifier. You got a couple of different flavors. I'll use a cylinder since I want to add a modifier to a hole, so a cylinder makes sense. And then you can put this modifier, we need to move it, we can put it kind of over one of the holes. Let's kind of get a overhead view here so we can center it up. You can change its size and scale it and all that. I'm just going to leave it like this. And what you can do here is, in this region, notice, oh, kind of over there. Notice it gave me a generic cylinder. That's the modifier inside this top nozzle box 1 file, the one that I'm working on. Okay, I can click this gear icon. Oh, do I have to right click? Why is it not bringing that up? Oh, all right. So if I click on it and give it enough time, then I can change a couple of different things here. One of them is related to layers and perimeters. Perimeters are walls. So I want to do that. So now I have this little modifier underneath the cylinder. So what's going to happen is, this cylinder isn't something I'm going to print. Let's see if I can, there we go. I'm not going to print that. Just everywhere it exists, it's going to modify the model that is going to get printed. So the one it's attached to, or whatever it overlaps, really. And so here's the perimeters, and I can just say, I want 5 walls where this little cylinder is. And if I slice the thing, notice how all the others have the, apparently I'm doing 3 walls with this print is the default setting that I have set, but where that modifier is, I've got a whole bunch more walls, but I don't have it everywhere. And I could rescale it, you know, maybe that's too big, so I can scale it down to, not in Z, let's scale it this way. Only like that, maybe. Reslice, so it's only that area. And I get my extra walls in that area. So that is, these modifiers are a way that you can go in and edit the way the STL file is going to get printed. So you can change layer heights in certain regions. You can change the number of walls. You can change the infill pattern. You know, I've got a kind of gyroid infill pattern, but I can go add another modifier here. Let's just do a box, and let's move it kind of in this region, maybe right here, instead of a gyroid. Oh wait, I will need infill for that. Instead of a gyroid, I want a grid. So everywhere that box overlaps my model, I get a grid pattern. This can actually be really pretty handy for changing infill in different places, but also remember, I printed this in TPU, and so I can get some really cool kind of metamaterial properties where in some regions of the model it's more flexible than others, or it's flexible in certain directions versus other directions. So I can create some interesting materials by modifying the infill position, density, orientation in certain parts of the model. So I can make it softer or harder in different places. It's the same thing with the other materials, but TPU obviously is more flexible, so it responds more to the infill pattern than the other materials do. So those are just some things where you don't even, sometimes, depending on what you're trying to do, have to take the model into some of these other programs. You might can edit it directly in your slicer. You can add text in here. So there is a text tool. I don't remember where that one's at. Scene painting, measure. Do I have to write on it, right click on it? Yeah, so I can add a part text, and I can add that nozzle text right on here. Except I don't know where it went. There we go. And I can make it a cut or a join or a modifier or whatever. Let's move it kind of centered up. So now when I slice, I've got the word nozzle written on the side of the thing. So you can do some editing directly in the slicer. Prusa slicer will do that. Just on your solid view of your platter, right click, and you've got a lot of different things that you can add. You can cut holes in. You can change where the supports are. You can do what we did with the increase the number of walls, change the density or the pattern of the infill. A lot of different things that you can do directly in the slicer. You can split the model. We did that earlier on, where you've got a large model and you need to split it into smaller pieces. Prusa Slicer is really good at doing that, and also at the same time it splits the model, adding in the location like a dowel and a hole so that you can actually line it back up when you go to assemble it. So Prusa Slicer is really pretty good for some of the simple STL modifying type things that you might want to do, and you don't even have to go to Mesh Mixer or Fusion 360 or any of those kind of things. I don't think they currently have a way to do any of the sculpting type things like reposing and stuff like that, but I wouldn't be surprised that at some point soon that's one of the features that gets added just straight into the modifier. Take some of the ideas that Mesh Mixer does and let you just sculpt, repose stuff without even having to go outside of your slicer. Right now I don't think you can do that. There might be a plugin that can do that for Cura, maybe, I don't know, I haven't looked. But those are some of the things you can do with STL files. We are really close to the end of the quarter. I've only actually got one class left on here, and it was just the one for the figures. It's where you submit your class contest thing. There is a quiz 3. It is just a survey, so you just go in and give comments on how to improve the course. There is a quiz 2 that I'm still trying to fix. It did not import correctly, and we didn't do it in the winter, and so I still haven't fixed it. And maybe Maybe we'll have quiz 2. If so, it'll be due on the 15th. But I don't know that it is going to get fixed up in time. If we do, we do. If we don't, we don't. It doesn't really matter. It's very similar to quiz 1. But now the main thing you need to be doing is getting all the different assignments turned in, uploaded. I've seen a lot of them. I haven't graded a lot of them, but I've seen a lot of them. And if there are any last minute topics, you know, we've got one class kind of scheduled and it doesn't even really have a topic. So if there's any last minute topics you want to try and put into the content, let me know. That's how this STL editing topic came out. So if there's any, let me know, and we'll do those on Monday. And otherwise, Monday will just kind of be a wrap-up overview kind of thing. But if you have a particular idea of a good topic we can put in there, we can put that on Monday. All right. We'll be back. We will be on Monday, 9:30 on Monday. And if you have a particular topic, we'll talk about that. Otherwise, we will do just some wrap-up, kind of finish out the course kind of thing. Make sure you know all the assignments that need to get turned in and that sort of stuff. All right. I will see you.